Hello, welcome students to this C Programming Lab session in which I'm going to explain you about sine series evaluation. So prior to evaluating the sine series, we need to know what sine series is. Okay, so sine series is nothing but the sum of the terms till infinity. The terms are like x raised to 3 divided by 3 factorial plus x raised to 5 divided by 5 factorial minus x raised to 7 divided by 7 factorial plus x raised to 9 divided by 9 factorial plus so on till infinity. Okay, so this is nothing but the sine series. And also observe, these individual entities are called terms. X is one term, x raised to 3 divided by 3 factorial is another term, x raised to 5 divided by 5 factorial is another term, so on. And also another observation is you can find the signs. The sign between the subsequent terms is alternating, that is, it is fluctuating from minus to plus, plus to minus, minus to plus, and again minus again. Fine. So this is the behavior of the sine series, and we have these terms. Here individual entities are considered to be as terms. X is the first term denoted as T1. X raised to 3 divided by 3 factorial is the second term, which is denoted as T3. X raised to 5 divided by 5 factorial is the third term, denoted as T5. Now observing the series, we come across the relation. Now if you observe this series, okay, we come across a relation, a formula. Okay, what that relation says is Ti equal to minus of Ti minus 2 into x divided by I minus 1 into I. So if you want to know this relation, we need to consider an example. Fine. So once again I show you the series. The first term is x. This can be also represented as x raised to 1 divided by 1 factorial minus x raised to 3 divided by 3 factorial, and also you observe the difference between the powers. So first term is having the power x raised to 1, the next term is having the power x raised to 3, so the difference is of 2. And also observe the third term, the next x raised to 5 divided by 5 factorial, the difference between 3 and 5 is again 2. Okay, so that is the reason we can find over here the in the relation as Ti equal to minus of Ti minus 2, the difference between the two terms is 2. Okay, next, as I said, we'll consider an example. So if T1 is considered to be as x, the first entity, the term is denoted as T1, that is x equal to T1 equal to x, considering I equal to 3. So here the subscript will consider it to be as I. So I considered as 3, it would be T3 equal to minus of T3 minus 2, that is Ti minus 2. As we observe the relation, it is nothing but Ti minus 2 into x divided by 3 minus 1 into x. In the relation we have over here I minus 1, as I is 3, so it is 3 minus 1 into 3. Further evaluating it, we get what? Minus of T1 into x divided by 2 into 3. Now we get over here the term T1. We get the term T1. We know that T1 is x. So substitute the value of T1, that is T1 equal to x, into this relation or this equation. So we get what is minus of x divided by 2 into 3, that is 6, which is nothing but minus of x raised to 3 divided by 3 factorial. So by this we understand what is knowing the first term, we can know the second term in the sine series, and knowing the second term we can know the next subsequent term, that is minus x raised to 5 divided by 5 factorial. Fine. So now we'll get into the programming aspects to solve this problem. Fine. So here we have the program. So the requirements for this program, we have I representing the ith value. Then we have x, which will be acting as an angle for the sine series. As we know that we are evaluating this sine series for a particular value of x. X is nothing but an angle. Okay. Then we have t representing the terms. Then the sum, which would be holding the final sum of the terms of the series. Next, we have a statement to enter an angle. So we enter an angle. So suppose we consider x as 45. That 45 value in x is converted to radians form. So it is converted as x equal to pi into x divided by 180. So x will be holding the radian form of the angle 45 degree. Okay. Next we have sum equal to x. In the series, if you observe carefully, we have the first term as x. Okay. So we initiate the sum variable to be as x. Okay. Then we have t equal to x. The first term is x when I equal to 1. So t1 is x. When I equal to 1, it refers what? T1 is x. Okay. So I equal to 1. Next we do what is, we have a do while loop because we want to sum up, we want to keep on adding the new terms. First term is x, we need to find out what would be the second term, and after getting the second term we need to add it to some variable. So we need to rely on a loop which performs the addition of the individual terms in the series. Okay. Now we have do I equal to I plus 2. So here I equal to I plus 2 refers to what? The next term. As I said, in the sine series, the subsequent terms, okay, have the power with the difference of 2. That is the reason we are considering I to be I plus 2. So if I is 1, I plus 2 would be 3. Fine. So this t here refers to t3. When I equal to I plus 2, here this t refers to what? T3. Okay. So T3 equal to the old value of t, the minus of the old value of t into x divided by I minus 1 into I. So the old value of t is nothing but x. Okay. So minus of x into x divided by I value is what? 3. So 3 minus 1. So this would be minus of x into x divided by I minus 1. I value is 3. 3 minus 1, that is 2, into I, that is 3, which is nothing but minus of x raised to 3 divided by 3 factorial. So this is what we wanted. This is what we wanted as the next subsequent term, which is nothing but T3. So now we have got T3 value. Okay, we can do what is, we can add the T to the existing value of sum. Existing value of sum is the first term x. Okay, so sum equal to sum plus t. When I say sum equal to sum plus t, the existing value of sum is what? X plus t. T is what? Minus x raised to 3 divided by 3 factorial. As there is minus over here, we get what? Minus of x raised to 3 divided by 3 factorial, which is nothing but 6. Okay. So this is how we go on subsequently finding out new terms First, the term was T1, next it was T3, next it will be T5, next it would be T7, fine. So every individual term that you find out should be added to the sum. Okay, so that will give you the final result available, that will give you the final result, and that would be available in the term sum. Okay, and also I said what is sine series is the sum of these terms which will go on till infinity. Okay, so I don't suggest, or there is nothing in programming like infinity. The program cannot get into an infinite loop and give you the result. An infinite loop is a loop which will never terminate. If it never terminates, then you are not going to get any result. Okay, now slight observation you need to consider is in this series, first term is x, next term is x raised to 3 divided by 3 factorial, next term is x raised to, so these terms if you consider individually, these individual terms which we are going to compute are going to become smaller and smaller. Okay, now if you consider the first term as x in radians, x raised to 3 divided by 3 factorial is lesser than the x value. Understanding? Next term, if I consider x raised to 5 divided by 5 factorial, which would be again lesser than the previous term. So, the subsequent terms that we are going on computing, they start reducing themselves, or they start becoming smaller and smaller, smaller and smaller, smaller and smaller, till it reaches some infinite. There is no infinite. They start becoming the terms, they start getting smaller and smaller. Okay, so for an example, if you consider, if I consider the first term to be as 1.2, the next term would be like 0.01. Okay, so the next term would be like plus 0.001. Next term would be what? Minus of 0.00045. Next term would be what? Again minus plus of 0.0000045, something like this. Okay, so when we see these terms, the terms are becoming smaller and smaller. Okay, and lastly you reach a point wherein adding those terms or subtracting those terms is not going to matter a lot. Okay, now suppose I consider a value like this, minus of say 0.000000000001657. Okay, so adding this term or subtracting this term from an existing term is not going to make more difference. Okay, so that is the reason over here we have this loop, okay, functioning for computing individual terms. Okay, how long are you going to, now we got x raised to 3 divided by 3 factorial, then next we are going to get x raised to 5 divided by 5 factorial. So individual terms we are going to keep on getting, and we are going to keep on adding them like this. Next term it will be x raised to 5 divided by 5 factorial. Okay, this will go on, and after this loop finishes we compare whether this term, okay, is it greater than flt underscore epsilon, whether this term is greater than flt underscore epsilon. So flt underscore epsilon is a constant declared in float.h header. Okay, so its value is something like 0.169 something one. Okay, so this is the value of flt underscore epsilon. Fine, so as I was telling, in this series we go on getting terms like this, we go on getting terms like this. So how long are you going to compute the terms? So we are going to compute the terms till the term is greater than FLT underscore epsilon. The meaning is till it is greater than this value. The moment it is smaller than this value, we stop. We stop. Okay, smaller, anything smaller than this value like 0 is smaller than this FLT underscore epsilon. So that time we stop. Okay, because I said adding such term or subtracting such term is not going to make much difference. Okay, so that is the reason we are going to keep on working in this loop till we reach FLT underscore epsilon. Okay, or else you can directly write over here, if you don't wish, 0.00000000123. Okay, this is also fine, because as I said, individual terms are heading towards something like this, negligible terms those are. Then lastly what we do is print the value available in sum, that is sum equal to sum, and also compare that with the built-in function sine x. Okay, so we need to cross verify whether the computed result manually through theoretical relations, whether the sine series value is it correct as computed by the built-in function sine. Okay, so let me keep it as FLT underscore epsilon, and we will check out, okay, for some angles the results. I'll save this and let's compile the program. G hyphen lm dot c sine dot c, then dot slash a dot out. We'll enter the angle as 45 degree. Yeah, so over here as you can observe, the value that we have got through theoretical relation computation is 0.707106, and inbuilt function also is giving me the same result. So it means what, the program that is been written or it has been coded is perfectly fine. So I hope you have understood this sine series program. Thank you.